Hello and welcome to the next Frog Tips episode. If you listen carefully to my previous videos, you know where I said that there will be a video showing how to make a DIY NPAS to set the power in the Tokyo Marui MWS system for the M4s. And if you listen not carefully, then you've heard that. So to answer the first question, why do you want to even make this kind of NPAS? The answer is pretty simple. It allows you to set the power you want in the GBBR, regardless if on HPA or green gas. This is the Noveski N4. This is my custom Angry Gun steel bolt carrier group with ArrayTech nozzle with magnetic NPAS, and this is the regular stock TM MWS M4 bolt carrier group. In the stock these guns don't have it. Mine has it, but it's not a good solution because if we look from the bottom, in the hole here you can see this gray spring-loaded part. This is the valve, and the valve in the VFC or WE NPASs can move all the way back to the end of the window here, and the more travel it has to the front, the more power you are able to set in the gun. So for this reason, if you have such a short travel, you will get very low power adjustment range. In this case, this is 1.3 joules on maximum on 0.28 gram BBs. Redline Mini SFR 120 psi, and barrel length 10.5 inches, 6.01 inner diameter. Definitely you could get more if you were able to set the NPAS to a more rearward position, but due to the construction of the nozzle you cannot. Maybe on green gas it works, on HPA it's not a good solution. In Tokyo Marui and the Noveski ones you can see the valve is more or less in the second half of the window here, so it could go even a little more to the back or to the front, and then we would get some adjustment of the power. Of course you could say that you can adjust the power in the HPA GBBR through the pressure on the regulator, but this is not the best way, as the final energy that you get in the gun comes from very many factors like the barrel length, barrel diameter, type of regulator, regulator flow, pressure on the regulator, weight of the BBs. There is a lot. If you adjust the power through pressure only, then you impact the whole cycling of the gun, the whole function. But if you do it through NPAS, then you can set independently pressure to nice operation of the gun that you like, and NPAS to muzzle energy that you need. So this is the reason why you want to have it. And in case of green gas, you have no way to drive the pressure of the gas. Maybe you can buy weaker gas, stronger gas. This is not a precise setting of the power. This is just, you know, bullshit. So these two bolt carrier groups have the same construction. They are not fully identical to each millimeter, let's say, but I will show based on the TM how to make the NPAS, and then I will show it made also in this one Noveski part. Obviously the first step is to disassemble it, so we need to remove the top part with a screwdriver. There are two screws on the top, second one here, and there is a spring here in the hole. To make it a little easier you can remove it now. This spring is kind of strong, but then you pull the nozzle out and you can remove this part by sliding it like this. You see there is a lot of oil inside. I can wipe it off later when assembling everything back. Of course we will have to relube all the parts. And where we want to get is the nozzle, so we remove this plastic part in here, and then we can take out the nozzle. With these parts taken out we can put them aside, and here what we have, there is a tiny screw here on top. We need to remove it. Okay, it's quite long, and then you are able to pull out complete assembly. And we can also throw out the inner parts. They don't fall out on their own in my case, so let's push them from the front. There should be the valve and the spring. You can remove this seal so it will be easier to take them out, because this seal holds them a bit, yeah? So now seal is out, the spring is out, and the valve is out. Okay, so a real quick reminder how this works. I spoke about this in one of my videos previously, the VFC NPAS, how to make it. Basically, this valve travels on a spring. When you shoot, you input the gas here. It travels through the valve, through the openings in the valve, through the spring to the nozzle front, where it propels the BBU. And the pressure on this side of the nozzle drops. The pressure that builds up also behind the valve pushes it, overcomes the resistance from the spring, closes the valve inside and fills out the cylinder that is created between this gasket and the bolt carrier. So basically it's thrown back. The longer it takes for this valve to travel forwards and completely close, the more power you will have. This is especially visible with longer barrel lengths. With small barrel lengths it's not such a big difference, but that's basically how an NPAS works. So now we are going to add the regulation to the valve. We will do it the same way like the VFC NPAS, and we are adding a headless screw into the middle of the valve. The dimensions of the screw is M2.5 × 8. You could also go for M3, and the length, I don't want to have it too long, not to choke off too much the valve. That's also the reason why I chose the 2.5 mm diameter. Although in VFC they have M3 screws and they are perfectly fine. If you are about to do a smaller range of hop-up adjustment, you can also use a shorter screw. When I complete the whole mod, you will understand what I mean. This is my choice, and I need to drill a hole through the center of the valve, through this rear wall, and I want it to be diameter 2 mm. Because then I can screw a screw inside, it will be quite tight, it will not loosen up on its own. This will be a perfect match. It will create a thread for itself, it will work just fine. If you were to go with the M3 screw, then you can use the 2.5 mm drill. Obviously I'll start with a smaller diameter and then enlarge it. This way the hole I receive in the final stage will be more precise. And this way I completed the next step. You see I have a hole here in the middle. This is again 2 mm in diameter. It's centered. If you don't know how to drill it nicely with home methods to have it in center, you can check the link in the description of the video. I'm using this kind of device that I can print. I can put in the valve in here, I can close it, and I have a hole here through which I put the drill, first 1 mm, and I can drill a center hole through. Then drilling it to a bigger size is very simple. Then the next thing you need to do is you need to look into the valve, because after this drilling and so on, definitely there will be some debris, like in my case there is one here, probably hard to see in the video, but I need to remove it, so I'll do it. And when the valve is clean, you can take your screw, and basically we need to thread it into the hole. It will go with some resistance. This is what we need. It should be more or less in center, and you see how it goes through. It also pushed out some debris, then we can remove it. Yeah, and now I have a nice clean working screw. Of course you see that the screw comes out on the other side, and here there should be some resistance for it. So if you only want to be able to drive the performance down, then you don't need to shorten this part. It's enough to make a support for the screw in here. You can see the cutout here. This cutout is because normally on the valve on the rear side, maybe you noticed, there is an injection point. It's not an even surface, so they did it so the valve stops on a surface that is always flat and always has a good shape. In our case, if we leave it like this, the valve would be going back and forth and the screw would be hitting against the plastic, and it will definitely cut into it, so it's not a good solution. So we need to add some metal reinforcement. Again, if you want to just decrease the power, this means that you need to move the valve more to the front, and you don't need to modify this part more than just adding this metal reinforcement on which the screw would sit. But if you want to increase the power also, or have additional range to increase the power, then this part will be too long and we will need to shorten it. And the maximum for me that is reasonable to shorten it is 3 millimeters, and you generally want to have it cut flat, so that this face is flat, obviously, but in practice the valve will rest on the screw and not on the plastic walls anymore. More important will be the reinforcement that we are adding than the actual cut that we will do right now. Okay, so you see I cut my valve, it's now shorter, and I need to add the part that will support the screw. As I said, plastic is not enough. So in my case, I will cut off completely the tab in between and I will replace it with a metal bar. But if you are not doing this cut, just adding the decrease in power, then you can just remove a portion of this bar and put support metal bar in between, and this way you will have less of the rib to remove. In my case, I can remove the complete rib, it's not a problem. Okay, so now you see I don't have this bar. I cut it off with a knife. These parts are very soft, so it's really easy. You don't need a lot of force or anything to do it. There's one more important thing I didn't mention. So generally when using these kind of screws, the best ones are the ones with flat tip. So you see, maybe like this is a tiny part, but the tip of this screw is completely flat. If you buy them, sometimes the tip can be sharp, sometimes it's like rib around a hole. Yeah, it looks different ways. Why this is important? This is because when the valve will be cycling thousands of times, the surface on the bottom will start to wear out. And if it will be sharp, then this tip would be flattened with each next cycle until it gets into some semi-flat condition. And for this time, basically the valve would be constantly changing the position, making the output rise. This happens, for example, in VFC guns, where the support for the screw is made of plastic in the NPASs, and when you shoot, the screw bites into the plastic until it creates kind of a nest for itself, and for the whole period of this breaking in, let's call it, the power slowly rises when you are shooting. Of course, it's not like it will rise 10 joules on one action. Yeah, it will rise 0.1 joule in 1000 rounds or something, so it's not dangerous or whatever. But you need to control it. So again, flat screw, and the best type of rib would be also a flat rib. You could ask what to use, and for example, if I use the regular round rod to be put here, then the screw will have small contact with the rod because it's round and the screw is flat. So this will not be perfect. So in this case, the best choice would be a hex key if you cut off a part of it, because it has flat side. So you can imagine that right now, when the screw will be sitting on that side, it will be a nice support. The screw will not slide to the sides or whatever. It will always sit flat on the flat surface. So what I will do is I will choose a hex key. You can use either 2 millimeters. This is 2.5. I need a 2 millimeter hole here. I'll make it tiny bit smaller so that when I push the key through, it sits a little tighter. It will not fall out because there is no space in the nozzle where it could fall out. So generally what I do, I drill hole through both sides. Important is that when I put the key through, it will stay perpendicular to the axis here, and that it doesn't obscure this hole for the screw which attaches to the nozzle. So it's really up to you. If you do the 2.5, 3 millimeters hex key, all is okay. The important is that the hex key has enough surface to support the tip of the screw, and as I said, for example, in this case 2 millimeters would be just fine. I will drill these holes, insert the key, the cut-off part of it, and I will show you how it looks like. And here I have my prepared part. So you see the hex key is inserted and it's rotated with the flat towards the screw. Yeah, so it will work like this. Plus, one thing that you might want to do is to actually secure it with glue so that it doesn't rotate or anything. It fits tight, but it should not be a problem. I decided to use that 2 millimeter hex key, as for this screw this amount of support seems enough for me. And when all of this is ready, we can basically put the valve back together. So we need to take the screw and the spring and put the valve inside, you can see that if you rotate it, there are 3 ribs from this side visible, but only 1 rib visible from this side. So if you point the nozzle opening to the top, that's how you insert the valve. Actually, there are guides that will not allow you to do it much differently. And then you insert this part, if like this or like this, it's no difference. This hole will align with this hole later on. So okay, so my parts are in, then I will put this screw in here and it should go through. At the end there is the thread, you know, this goes into the plastic, so not to damage this plastic thread, I will rotate it counterclockwise to find the previous thread that the screw did in the plastic, and then I will screw it in. This way I avoid making damage to the nozzle. Okay, and don't secure it too tight, just fine. Yeah, you see the screw came out this side. What you can see right now, that the valve is at the very end of the nozzle, and I can take the key, I can insert it into the screw. I caught this screw with it, and when I will be turning it clockwise, you see how the valve starts to move forward. This will give me less power. And again, I chose the 8mm long screw, and I will have some limitation because I don't want the screw to pop out of the part, obviously, so I need to stop at some reasonable distance. And now this was the clockwise direction. When I will be turning this counterclockwise, you will see that the valve rotates partially, but then the screw starts to come out. So there are 2 options. Either remember that after increasing the power, you always need to rotate the valve back, and there is this tiny dot on the valve that is visible here, so it has to be pointing downwards, yeah? Or you can just insert some screwdriver in here to hold the valve in position, just like you do in all non-magnetic type of NPASs from the Array Tech 4WE. So again, you see that right now the valve is moving back, so the power would increase, but it rotated a bit. So at the end, when I finish setting, I will push it back into proper orientation. If I again decrease the power, rotate it clockwise, you see this doesn't really happen. Then I can remove the hex key. Now the only thing left to do is to put back on the seal and reassemble our bolt carrier group assembly. And this is very simple. Remember to apply some lube. If you are opening an already used bolt carrier, then you can clean it up, use the occasion. Then just drop in the nozzle, screw up, opening down. So when it is in there, you can see the silver part comes through. You need to pull it to the back and catch it with this plastic part in position. There should be some resistance, at least a bit. When this is done, you need to assemble the plastic guide on the top. So you pull the nozzle out and you slide it from the front like this, very simple. Everything works nicely. Then we attach those 2 screws. We tighten them down. And the last part will be the spring that goes in here. It's kind of stiff and I always have issues to put it in. But what you need to do is compress it so much with some kind of screwdriver that it catches on the pin on the plastic part, basically. So you need to basically compress it so much that it goes in there. So with some help of screwdriver I made it, and right now this plastic part has this kind of movement. So what is left is to drop the bolt carrier group into the gun, obviously relube it first, set proper power and shoot. I will show you reasonable minimum setting, the maximum setting I will show you on the chrono, how these 2 settings differ. Please remember that I'm shooting out of the stock TM M4 MWS, and it has a very short barrel. Outer barrel is 14.5 inches and the inner barrel is only for 10.5 inches version. So the power would be limited. I don't know what diameter it has internally, but generally if you apply tighter diameter and longer barrel, you can increase the power even more. Right now this is a stock gun, so all I want to show you is how this modification can allow you to drive the muzzle energy that you get in the gun. Okay, so we are doing the low power setting. This is 0.28 gram BBs, Redline Mini SFR 120 PSI stock TM gun. 1.11 15 joules, and now the high setting. So you see it's around 1.4 joules. And here is the assembled Noveski bolt carrier group. It has the same modification. Basically, there are some tiny differences, but the general way how it works is the same. The valve is modified. If you take out the valve, you will see that it's tiny bit different, but I modified it with the exact same 3D printed tool, and it's perfectly fine. I used the exact same type of screw inside. The difference is that this valve, maybe in other guns it's better, but at least in mine, when I rotate the screw, the valve fully rotates, so it's like WE. This means that in order to set some value, I need to hold it down in place. Which means that when I catch the screw, I need to insert screwdriver through here to hold the valve in place. Of course I can insert something else, and now I can move the screw. The process is exactly the same as in the Array Tech regular NPASs for most of the guns. Always remember, because this valve rotates easily, but one side is without the rib visible, so always after finishing setting up the muzzle energy, set it with the missing rib towards this window to give it maximal flow. I tested it and it doesn't rotate while shooting, so it should be perfectly fine. In case of the Noveski, I achieved the exact same values of muzzle energy possible to set as in the TM, because the inner barrels are the same, parts are more or less the same, so the performance you get is more or less the same. Okay, and this is everything for this episode of the Frog tips. So you've seen how it works. You see that with this simple modification you can modify the output of your gun. Actually, in this setup I was able to go down to 0.5 joules. It was a little unstable, but it was possible. What does it mean? Again, it means that if you assemble a longer barrel and a tight bore barrel, better backing, you would get much higher powers. Instead of minimum half joules, probably you would end up with like minimum 1 joule. Instead of maximum 1.45 joules or 44, probably you could end up with like 2.5 joules. Of course, on the green gas, the NPAS will work the same way. Muzzle energy levels that you will achieve will be basically different, because this is a different gas, different pressure, but the effect of decrease, increase will be exactly the same. Why to make this mod? Because the complete cost of it is just one screw, and you really don't need to buy any expensive nozzle to have some tricky, weird NPAS for lots of money. As I explained, especially for the HPAs, the magnetic ones have very low adjustment range. Here we can reach much higher values of muzzle energy, and the gun performs normally. One more thing I didn't mention yet: when you increase the power, obviously the valve will take more time to close, so it will decrease the rate of fire slightly. When you decrease the power, it will take less time for the valve to close, therefore you will increase the rate of fire just a bit. Of course, using heavier BBs, higher pressure on the regulator also increases the power. So this is just a sample. So this is all for today's frog tip. If you like the video, then let me know, give me likes, subscribe, leave comments. Definitely hit the notification bell, because there will be much more information like this coming for all the systems of the GBBRs for which there are the Frog Engineering HPA GBBR conversions. And if you want to learn more about these conversions, then have a look into the Check My Rec videos or the Frog Manual videos, where you can see how they work and for which guns they are applicable. And for now, thank you for attention, and may the power of GBBR be with you.